So today's video is going to look at finding angles of a right angle triangle and how we use the trigonometric ratios of sine, cos and tan to do this. So because we're going to be using sine, cos and tan again, we're going to have to recap on how we label our triangles. So take this right angle triangle for example. The side opposite the 90 degrees is always the hypotenuse. And I told you that this is usually the longest side of a triangle. Now, when you're labeling the opposite, it's always the side that is completely opposite or the mirror to the angle. So in this case, A is the angle, so this is the opposite. And then the last one is the adjacent, or the last one not to be labelled. And then sine A is opposite over hypotenuse, cos A is adjacent over hypotenuse, and tan A is opposite over adjacent. And we remember this with SOHCAHTOA. SOHCAHTOA. Or you can remember it as silly old Harry caught a herring trawling off America. There's loads of different analogies. You can make up your own one if you wish. It's just a way for you to remember the ratios. Okay, so again, quick recap. We're just going to label the opposite, the adjacent and the hypotenuse on each of these triangles. So pause the video now and give yourself a couple of minutes to see can you label them before I go through them with you. Okay, so for part 1 we have, well, this is our 90 degree, so 5 must be our hypotenuse. So we label hypotenuse is 5. And I told you that when you have an angle, the side directly opposite that is always called the opposite. So our opposite is 3, and then the last one, or the one we haven't assigned, is 4. Okay, so let's take part 2 then. So A again is down in the corner here. So 12 is our opposite. The adjacent then, well, it can't be 13 because 13 is the hypotenuse. So the adjacent is 5. And for the last one then, we have, well, 21 is directly opposite the angle A. So 21 is our opposite. Directly across from the 90 degree angle is 29, so that's our hypotenuse. And the last one left is 20, so that's our adjacent. Okay, so let's get straight into it now with an example of how you would find an angle in a triangle. Now, it is extremely important to note that you are going to need a scientific calculator for this. Otherwise, you're not going to be able to find the angle because you won't know what sine 35 or cos 40 is. Okay, so we're told to consider the triangle ABC. So here we have ABC. Now, it's a right angle triangle. We know that from the symbol down here, the little L, or the backwards L even. And then we have our angle here of 35 degrees. Now, it's a little different to the questions from before because usually we had 2 sides and we were missing 1. And that's when we used Pythagoras. But now you're going to use the ratios and you're going to use the 8, the x and the 35. And I'm going to show you how to do that now. So step 1 is label your diagram. So here's our H, our hypotenuse, okay, the side opposite the 90 degree. I have my angle in this question, so x is O and A we don't know, okay, so that's not necessary. Now, if you remember that sine, okay, is opposite over hypotenuse, and we have the opposite, or we have the hypotenuse, sorry, and we're looking for the opposite, and we have an angle, so we use sine to find x. So use the diagram to write sine 35 as a fraction in terms of x. So that's what we're going to do now. We're going to write sine 35 as a fraction. So our answer is going to have x in it, and that's fine. So for part A, we're told to write sine 35 as a fraction. Well, sine, okay, equals opposite over hypotenuse. So sine A, we just call it A because that's what the angle is, angle A. So sine A is always O over H. Well, by that scenario then, sine 35, because that's the degrees that we have, equals, well, O we don't know, so we call it x, over 8. And that's part A done. Now if we look at part B, it says use a calculator to find sine 35. And this is exactly like one of the learning checks from the last video. So for part B, it's very straightforward. We need our calculator and it's simple calculator work. So sine 35. What does that equal? Well, if you go to your calculator and click sine 35 and press the equals button, you will get an answer. It's going to be quite long. It's going to start with 0.57 5735 and it goes on. Okay, now you're told to give your answer correct to one decimal place. So your answer is going to be 0.6. So sine 35 is 0.6. That's how you can say it as a decimal. Now, use your answers from part A and part B to find the value of x. So you're actually only doing algebra here. So your answer for A was this. This was A. And your answer for B was 0.6. And you're told to find the value of x. Well, if you think about it, x is in this equation here, this expression here, and we have sine 35. What did we just figure out? Sine 35. So instead of writing sine 35, we write 0.6 and we basically cross multiply them and that will give us what x is. So let's see, can we do that now? So let's rewrite it. We have, so for part C, we have sine 35. So we have 0.6 instead of sine 35 equal to x over 8. And here is where I cross multiply. So I'm going to say, well, 0.6 times 8 will equal x because I'm cross multiplying. So 0.6 times 8 equals x. Well, if I multiply using my calculator 0.6 by 8, I will get x. And x in this scenario, when I multiply them, is 4.8. So the length of the side x is 4.8. So here we have another example. We've got a right angle triangle, A, B, C. We've got the length of AB is 10, the length of AC is x. We don't know what CB is, and we have 60 degrees. Okay, well before we can even begin to answer this question, we need to label our triangle. And this is a very, very good habit that we get into when we're answering these questions. So let's label it. Well, the side opposite my 90 degrees is H, so x is H. The side opposite the angle is always O. Now we don't know what O is, but that leaves that 10 is A. Okay, so now we need to look at our trigonometric ratios, sine, cos and tan. Well, we can't use sine here because you need O for sine, you need the opposite. But we could use cos because we have A and we need H. And cos is the adjacent over the hypotenuse. So cos A, if we write that out, cos A is equal to the adjacent over the hypotenuse. Okay, in part A, they're asking us to use the diagram to write cos 60 as a fraction in terms of x. Well, just like the last question, we're going to say, well, cos 60 is equal to A, which is 10, over x, which is h. So that's part A answered. Part B then is where we get our calculators out again and we say, well, cos 60 is equal to something. So we'd get our calculator, we click cos, which is here, we type 60 and we press the equals button. So do that now and see what you get. So when you put that in your calculator, you should get 0.5. Okay, so that's part B answered. Now we move on to part C, and it says use your answers for part A and part B to find the value of x. So they're basically asking us to do the same thing as the last example, substitute in 0.5 for cos 60, and that will give us what x is. So let's do that now. We'll say, well, cos 60 is basically 0.5, so 0.5 equal to 10 over x. Because all I did there was, well, I know that cos 60 is the same as saying 0.5, so I just put 0.5 in here instead. And then I kept my 10 over x. Now, in the exact same way, you're going to basically multiply both sides by x, or cross multiply. So you're going to say, well, 0.5 by x and 10 by 1. Well, 0.5 by x is going to leave you with 10 equal to 0.5x. So when you do that, you're going to get 10. So that becomes 10 equal to 0.5x. Now, if you want to get x on its own, you need to divide the two numbers. So you're going to have to say, well, 10 divided by 0.5 will give me x. And when you put that into your calculator, you're going to get that x is 20. And that's that question solved. So give these two questions a go now, and they're based very similar to the two examples that we did. So hopefully you'll be able to follow exactly what I did in the other examples, except with these scenarios instead. And make sure that you've taken down those other two examples as notes as well.